I'm just recording problem set number 2, and the intention is to help you understand this topic because this chapter is really important. And I say, do not give up, just try your best. Problem set number 2 on chapter 3, vectors. Now, first of all, remember that if you have a vector A and a vector B and you want to add them, so you're trying to find the resultant, you're trying to find the sum of the two, all you got to do is fit the vector B onto the head of vector A as done here. So first draw vector A, then connect vector B to its head, and if you join the two endpoints, if you join the endpoints, you're going to get the resultant, which is R here. So that's how you add vectors. Now that could be done geometrically. Well, that's just a hint to begin with. Now, problem 1 talks about walking 8 meters straight west, then 25 meters straight north. All right. So that is the diagram. 18 meters to the west, you go that way, and then you go 25 meters to the north, straight north. And the question says, how far are you from your starting point? Well, AC is your distance from the starting point, and to find AC, all you got to do is AC squared is AB squared plus BC squared. Square them and add them, take the square root. 30.8 meter is the answer. Now, if you want to find the angle, you can use tan theta, and tan theta here, remember, is opposite side by adjacent side. The side opposite to the angle is 25 meter, and the side adjacent, means nearby, is AB, which is 18 meters. So you divide them, you get tan theta. And then you take the inverse of this on your calculator. You find the angle in degrees, 54.2 degrees. There may be an overlap of the recording here because there was a small problem. Anyway, you got to find the x component of the vector, which is, well, first the angles are given, run through the angles. I think you got that. That's vector A, that is vector B. And the x-axis and the y-axis. This total angle is 49 degrees. And that's the angle that you need, because you always need the angle that the vector makes with the x-axis. Now, because you got that, you can find the x component of the total vector. All you got to do is multiply the magnitude of the vector, 6.72, with cosine of 49 degrees. When you do that, you get 4.409 meter per second. That is the x component. And the y component would be 6.72 sine 49. And this is always the case. The x component is going to be cos, and the y, the vertical, is going to be sine. Now, as drawn in the diagram, that is the total x and the total y. Okay. Now the arrows represent the component of VA along the x-axis, as you can see, and the component of VB along the x-axis. So that is VAX, and that's going to be like before, VA cos. Now the angle is 22.5. Look at it carefully. We do not know VA, so we'll just put 0.9239 VA. Similarly, VBX would be VB cos, excuse me, VB cos of that angle, because that's the angle made with the x-axis, and that angle is 72 degrees. You know that from the small triangle there. Okay, so take the cosine 72, which is 0.3090. So you got that. Similarly, that is VAY and VBY. Now, how do you find VAY? VAY is just VA sine 22.5. Remember, the vertical component is always sine. So that's going to be 0.3827 VA. And this is VBY. And what is that going to be? That's going to be VB sine 72 degrees. I've slowed this video down so that you have enough time to understand. So now we resolved both the vectors into its components. And if you carefully look at the diagram, you understand that the x component of the total, which is this one, is simply the sum of VAX and VBX. Is that clear enough? Okay. So substitute the values. VAX is point, and this must add up to 4.409 because we already got that. That it must add up to 4.409. So now we got an equation. 0.9239 VA plus 0.3090 VB should be equal to 4.409. Now do the same with the y component, because when you add the two y components, you must get this total, isn't it? Yes. So VAY plus VBY should give you V total y, which is 5.072. Therefore, 5.072 is equal to 0.3090. No, I'm sorry, 0.3827 VA, which is this one, plus, we're looking at the y components now, 0.9511. So we have two equations that you have to solve in order to find VA and VB. There are several ways of doing this, but it's good if you divide one equation by 0.9239 the first equation. So we are able to separate it. Now let me speed this up. So then you get, that's by dividing each term in equation 1 by 0.9239. Okay. So now you have VA, and you can substitute that into equation 2 in place of what you find here, VA. So when you substitute, see, that's in place of VA now. This whole thing. Okay. So now you collect the two terms that have VB in it. First you have to distribute and solve. You get 3.94 meter per second. And then when you substitute back, you get VA as 3.45 meter per second. So that's the A part. In the B part, you're asked to find the components of V total along the X and the Y axis, and we've already done that. Okay, so now on to question 3. Question 3 says that you fly 32 kilometers in a straight line in still air in the direction of 35 degrees south of west. Okay, so that's how you fly 35 degrees, and this has to be slowed down. Okay. And it says find the distances you would have to fly straight south and then straight west as given by the dotted arrows. When you're going straight south down, and then, okay, that's straight south and then straight west. Okay, so that's your vector A. Remember that this is going to be AY, this is AX. That angle is also 35 degrees, because parallel lines cut by a transversal alternate angles are equal. And therefore we remember that AX is always whatever the vector is, in this case it's 32 cos of the angle, which is 35. So it's 32 cos 35. That is 26.21 kilometers. And similarly, AY is 32 sine 35 degrees, which you calculate as 18.35 kilometer. Okay. Now the B part, it says find the distances you would have to fly first in a direction 45 degrees south of west, and then in a direction 45 degrees west of north. That's kind of tricky, but here it is. I'm going to draw it to go 45 degrees. So what I do is consider that the whole set of axes, X and Y, is rotated through 45 degrees. Makes it easy. So you call it X prime and Y prime. You have rotated the XY axis. This is the original X axis, and that is the original Y axis. So your diagram is now simplified. Remember that is 45 degrees. So now your whole diagram is simplified, because now you see I've called it distance southwest and distance northwest. Okay. The angle is surely 10 degrees, because it was 35 before You've rotated the axis through 45, so obviously that's 10 degrees. So now all you got to do is find the components. You find the components, you get the southwest, it's 32 cos 10, which is, well, yes, I'm sure I calculated after writing this down, because distance northwest would be 32 sine 10. That's kind of slow now, okay. So you get the first one is 31.51 kilometer and the second one is 5.56 kilometer. That's the answer. And you know that if the speed appears to be a little bit fast for you, you can always pause and go back. And so I'm going to continue with an optimum speed. In the fourth one, in the fourth question, it talks about a projectile being launched at ground level with an initial speed of 50 meter per second. Okay. So at an angle of 30 degrees above the horizontal. So that's the direction in which it was launched, and that's the path that it takes. How much was that? That's 50 meter per second. That's the vector. And the angle is 30 degrees. So what do you do first? You resolve it or break it down into its two components. Okay. It says, what are the x and y distances from where the projectile was launched to where it lands 3 seconds later? So that's the x distance, and that is the y, as you can see. Okay. You break it down into its components, you get VOY. I did not switch on the sound for some time, but I hope you can understand. Well, remember that the x component is going to be 50 cos 30, and that the x component never changes. It's a constant. So the only equation that you can use is x is equal to VOX times t, and therefore you get 43.3 times 3, which is 129 meter. That brings us to question number 5. And in this question, a ball is kicked with an initial velocity of 16 meter per second in the horizontal direction and 12 in the vertical direction. Okay, here you see that already the components have been given, and so there's no need of doing any cos or sine, as you may realize. But the one thing that you have to remember is when it says at what speed does the ball hit the ground, remember that the horizontal component of the velocity never changes. So the 16 meter per second will continue to be 16 meter per second all the way until it just hits the ground. But the vertical velocity, which is 12 meter per second to begin with, is going to decrease and is going to become 0 at the maximum height. But then after that, it's going to increase and get back to exactly 12 meter per second in the opposite direction just before it hits the ground. So what we have to, just to find the speed before it hits the ground, just find the speed when it starts out. And for that, use AC squared is AB squared plus BC squared, which will give you the vector AC. So that's 16 squared plus 12 squared. Take it as 256 plus 144, that's going to be 400. And therefore when you take the square root of 400, you get 20 meter per second. So that's the velocity with which it started out, and that's exactly the velocity with which it's going to finish. In the second part, or B part, you're asked to find how long the ball remains in the air. So you got to find the time. Now to find the time, you only consider the vertical velocity, which is 12 meters per second. So you only consider the vertical velocity. A is negative 9.8 meter per second squared. You're looking for the time, and remember that delta y is 0. Why? Because vertically it has not gone anywhere. It starts from the ground and lands back on the ground. So totally, if you look at it, it's not traveled along the y direction. That's why delta y is 0. T question mark. And the equation, of course, is the king of all equations. Delta y is v naught t plus 1/2 at squared. Substitute into this. You get 4.9 t squared is 12t. Cancel the t's. You get 2.45 seconds. In the C part, to find the maximum height, again you use the vertical component because that's a displacement in the vertical direction. A is negative 9.8 as before. You got to find delta y, but remember this time you're only considering half of the motion. Therefore, at the maximum height, the final velocity is 0. So it's very important to understand that. In this case, you're only considering half of the motion. That's why the final velocity is 0. Now that's the equation that you use in this case. And when you substitute, at 19.6 delta y, when you take it to the other side and solve for delta y, you get 7.35 meter. Okay, now I think the maximum limit on YouTube is 25 minutes, and I'm already at 23.26 minutes. Therefore, I can only do 5 problems, and if possible in a second video as part 2 I'll try to put the remaining problems. Thank you.